Welcome, everyone. I know you don't usually do two-part sessions, but this could probably do with a lot more parts than two. So I think we're just going to scratch the surface on some analysis of O Net data in Python. So let me drop a link in the chat, and this is some code that we'll follow along with. So just to be sure, has everyone downloaded Python? Does everyone have Python downloaded on their computer?
No.
No. Okay. So if you have not, then there's a link to download Python in the Slack channel and in the chat through Anaconda. So anaconda.com/product/individual. That's a Python distribution company. So you can download Python, it's totally free. Might take a few minutes.
Does it matter which version we download? It seems like
you should do the latest version. 3.6 or 3.
What is the difference between a graphical installer and a command line installer?
Graphical installer is for non-computer scientists.
Okay, I'll do that one.
So yeah, yeah, for most people.
Everyone here is a computer scientist, so we didn't need to worry.
And hard, yeah.
Yes,
exactly.
Okay, so while everyone's installing, I'll give a brief intro into the types of stuff we can do. And actually, maybe I'll share my screen and just go through the notebook, and then we can you know, I'll give you like a preview, and then we can get deeper into the weeds. Sound good? Cool. Let me share my screen. Okay. Okay. One sec. All right. So so this is the Python notebook. Does everyone see it? It should say an exploration of occupations on top. Cool. All right. So I'll give a little bit of preview. So first we install Python packages. And by the way, I want to apologize. I have you guys on my second screen and the code on the first screen. So if it looks like I'm not looking at you, I am looking at you. Okay. So we're installing packages. I'll talk a little bit about Python packages and how we use them. We're going to read in some data from the internet. You don't need to have any data files on your computer. We're just reading them straight from online. We're going to clean it up a little bit. So we're going to get data from the Bureau of Labor Statistics. We're also going to get data from O Net. So O Net is here's a little bit about O Net. It's I don't know what it stands for. Occupational. Oh, here we go. Occupational Information Network. So it's a government taxonomy of occupations put out by the Department of Labor. I actually have a book here, which is when O Net came out. It's called The Database for a Changing Economy. It's all about O Net, the good, the bad, and the ugly. I'd maybe recommend it. Okay, so and then we're gonna read in some data from the O Net site about the composition of occupations. So we're gonna explore what O Net thinks an occupation is involved with. So all the activities involved in an occupation. And then we're gonna merge this O Net and Bureau of Labor Statistics data together. We're gonna group it, we're gonna filter it, we're gonna do a bunch of things, and we're gonna create pivot tables and create a representation of what an occupation is through its activities. And then we're gonna visualize that in a little hover plot. So you'll make these little interactive plots. Those are always kind of cool. And then we're gonna see what occupations are similar to each other. So we're gonna look for the most similar occupations. Then we're gonna look and see if you want to change jobs, what you need to do differently. And then we're gonna polish it up and make it all clean and nice. So that's on the agenda for today. So let me just stop here and see that for people who just joined, I I posted a link here for a GitHub. So this has all the code here. So everyone should be able to see the exact code that's in my notebook, but online. So you can just copy and paste this into your own notebook. So let me tell you a little bit about how to open a Jupyter notebook. So this is called a Jupyter notebook. And if you're new to Python, there are two ways to open a new notebook. So if you are on a Mac, you will need to open a terminal. Oh, it's not responding. Okay. And in the terminal, let's see. You will need to type in oh, actually, sorry. Do you see this? Am I sharing my whole screen or just? Oh, okay. Sorry. So you'll need to open the terminal and you'll have to type in the following. I'll post in the chat. Okay, so you'll need to type in Jupyter notebook inside the terminal. And then you should see something like this. This should open to your documents. If you are not a Mac user, if you have Windows, you should be able to open your window and you should see something called Anaconda 3. And under that, there will be an option to click on Jupyter Notebook. So you should be able to access your directory. So this is just my files on my computer. You'll see something totally different. And then you'll have to go to new Python 3 notebook. So you'll open a new notebook and it'll look like this. Sound good? All right. So I hope you're all able to open this notebook. The first thing we're going to do, you can make a title if you want. If you want to make a title, you can write a markdown cell. Markdown is just for writing text. To make things bold, you do a little hash sign. You could say, you know, new notebook. And in order to execute the cell, you press Shift Enter. So Shift Enter is the way you execute a cell. You can type in whatever you want. You could do 5 + 3, and you'll get some answer. So this is kind of how you navigate the notebook. Whatever you want to type into a cell, you execute that cell by pressing Shift Enter. Okay. So the first thing we're going to do is we're going to import packages. So a little bit about Python is that it is an open source programming language. So what that means is that it's, first of all, completely free. Second of all, it means that anyone can add to it and contribute to it, and those contributions become publicly available. So a lot of people write functions in Python and then upload those functions into a module or a package that they give some name to. So Pandas is probably one of the most popular, if not the most popular Python package, and that is for doing tabular data analysis. So basically anything you can do in Excel, you can do with Pandas, plus a little more. So Pandas is something you want to import basically every time you use Python. The convention is to call that PD. So you can import Pandas as PD. So you can execute this cell. And again, execute is Shift Enter. So, and you can copy this code from the GitHub page right here. You just copy that and run it. So, okay, so Pandas is for doing regular data analysis, tabular data analysis. We also imported something from SciPy. SciPy stands for Scientific Python. And what that enables is the ability to compute distances, among other things. You could do a lot of cool scientific analysis with SciPy, but the one we'll use is computing distances in high dimensional spaces. So things are bound to get kind of high dimensional. So we're also importing something from called tsne. It's pronounced T-SNE. It's from sklearn. Sklearn is the machine learning package in Python. And tsne is a type of unsupervised machine learning. It stands for T-Distributed Stochastic Neighbor Embedding. It's pretty fancy. And basically what it does is it takes data with lots of columns in a high dimensional space and reduces that to 2 columns in a way that maintains distances locally. Basically, close distances stay close and far distances can deviate. We'll see a little bit more about how it works, but it's really cool for visualizations. And then we're going to import Plotly Express. So Plotly is a plotting package where you could do interactive plots. So rather than a static visualization that's just a picture, we're gonna create plots where you can hover over things, you can drag and drop, you can kind of interact with them. So those are really the 4 packages we're going to use. Questions?
Everyone is still keeping up?
Okay, good. So the first thing we're going to do is we're going to download data from the Bureau of Labor Statistics. So if we go to the BLS page right here, here's a bunch of data. So what we're really looking for, we're looking for occupational, just some basic data on occupations. How many people are in each occupation in the US and how much they get paid. So the table that has that is table 1.7 here. So if we check out this table in a new tab, this is what it looks like. So it's got all these occupations. Each occupation has a code. That's called the SOC code, SOC for Standard Occupation Code. And it's got this little 2-digit - 4-digit thing. Some things are summary occupations, like total, and then line items are specific occupations. And then there's how much employment there is in 2018. That's close enough to the present, so we can use that. There's also the median wage, which is also an interesting thing to know about an occupation. This is data from the US specifically. So if we want to download this data, we could download it in Excel, and we can see what it looks like in Excel. It's going to look exactly like this. But another thing you can do, you can right-click on this thing and copy the link address. So you can see kind of at the bottom of the page, when you hover over any link, it shows you what the link is. So we can just copy that link address, and here we could paste it there. And this is the link here. This is what you would download. This is the URL that would give you the Excel file. Now we only want one table in that Excel file. There's a lot of different sheets. And if you look at this data, it's kind of a mess. So the problem is that there's a lot of, if you actually download this in Excel, you'll see that there's like some garbage rows up top. Every title is actually 2 rows. It's a little messy. There's some things at the bottom that are unnecessary. So when we read in this Excel file, we have to skip rows. The header is actually 2 rows. We want to skip the footer. We kind of want to do a little bit of massaging with this. So when you read in an Excel file, you can choose the sheet name. You can also do some cleaning, but that's fine. And because the headers are a little bit of a mess, we're just going to rename them. So what we did here, we read in data from the internet, and we named that BLS. So now there's something called BLS, which is an object in our memory. So that is something that we can play around with, and we can see what it looks like. We can press BLS. So and we can see it reads in this table. So now we have this table in Python. We renamed the code, and also wage is a little bit messy because there's like $signs, there's parentheses, and we just want to remove those. So here, this whole thing is about cleaning it up so that we can convert it to a numeric column, so we can like do math on it. There is lots to say about cleaning data in Python, and I don't want to go into too much detail about this. But I will make a shameless plug for my course at NYU that has a lot of material that you can look up. So here's this course. It's nyu.databootcamp.com. If you want to learn more about cleaning data, there's an ebook on this that has a lot of good resourcing code and everything. And you can use this. It's totally free and open source. So if you do want to get deeper into cleaning data or reading in files or any of the nitty-gritty around that, that's a great resource.
Then if I could just say that we have also a bootcamp in Python. Bennett, your friend Bennett is teaching it in SPS. So you don't have to go to Stern for this. And we also have Miriam here, who is going to be teaching SQL as well. So there are lots of these opportunities. Thank you. Thank you very much.
Yeah, and they're both incredible. So if you have the opportunity to take the class, you definitely should.
And Ben, there are a couple of questions in the chat.
Yeah, sure.
One is Sonia is not able to find the Plotly. And then Himani was asking, how do we identify what needs to be cleaned?
Good question. So if you download it, so if you download it through Anaconda, then Plotly should be installed. Is anyone, are other people having this issue after having downloaded this in Anaconda with Plotly?
Yeah, I had that issue.
Oh, you did?
It's in Anaconda Navigator, so you have to go there and just install it.
Oh, okay. Sorry about that. It should be pre-installed with Anaconda. But yeah, I mean, another thing you can do is in your terminal, if you want, you can also type in conda install Plotly. And that should also work. You can also do it through Anaconda Navigator. Sorry about that. Yeah, and then you should be able to import plotly.express as px, and that should work perfectly fine. So the other question: how do we know what needs to be cleaned? So it's a good question and a hard question. I think let's say that we just read in this file here, and we just got BLS that way. So now we have this object BLS, and if you look at the column headers, they're kind of a mess. I mean, we have all these names that are like, don't really make a lot of sense and aren't easy to call. So it just kind of perusing it is a good way to see that, like, okay, we got to rename these columns. You know, it's not easy to navigate. Another thing you can do to check out which columns you might want to change is you could do D types. So D types specifies the data types. And for every object, for every column, you can see how it's stored. So employment is a float, which means a floating point number, which means it's numeric. It's numerical. But for medium wage, it's stored as an object, which means it's not numeric. So, and that isn't really what we want. We want it to be stored numerically. So that gives us a hint that that when it got read in, there were some special characters that didn't allow it to be stored as numeric. There are also other things we can check out. We can see, you know, how many nulls there are. There are a lot of diagnostics we can do once we read in our data.
Quick question. So how can we actually convert those objects into the numbers so we can actually manipulate with them in Python?
So that's this line, pd.toNumeric. So yeah, so here's what we're doing. Here, let's say we do this cleaning. We can do these all on different lines. And let's say we look at BLS wage. So this is how we select one column. So we select one column just by putting brackets around it. And if we want to select a string or just a name of something, we need quotes. So we're selecting the column wage, and it is, and you see the D type is an object. So we could try pd.to_numeric, which is the function to convert it to numeric. But we're going to get an error. So the error is it's not able to parse this string dash. So it looks like there's dashes here. So we got to remove the dashes. So basically there's like a way to basically we can look for any of the non-numeric objects. Once we remove the dash, we're going to come up with something else. We have to keep removing these things, and so there are string methods. So I went through a few different string methods where we're replacing a greater than or equal to with nothing. We're replacing the dash with nothing. We're replacing $sign with nothing. Replacing comma with nothing. So we're doing a lot of replacements with nothing. also sometimes there's what's it called? There's a parentheses, and we don't want that. We want everything to the right of the parentheses to be removed. So this is the code which does that. Yeah, there's basically a lot of, you could spend a lot of time cleaning string data. So there's a line that I like that 80% of data science is cleaning data, and the other 20% is complaining about cleaning data. And that's very true. So this could take forever. But I'll give you this, you know, so that you don't have to worry too much about it now. But if you do want to really dig into like how to clean these things, you can dig into each command and see if it makes sense to you. So now that we've run that, now we look at wage, and you see the D type is a float, which is great, which means we can calculate a mean, and that's the mean wage. We can calculate standard deviation. We can, you know, we can do a lot of cool stuff now that we have it. So okay, so we can check out the data now that we've cleaned it. Now that we've done everything. So we've got our occupation. This is our occupation name. We called it occ. We've got our sock code. That's the encoding. The type, whether it's a summary or a line item. By the way, when we do .head, that is that's something we can do to a data frame. A data frame is the whole table, and that just shows the first 5 lines. We could, of course, do the first 10 lines if we do 10 there, and that's also fine. So we can see the employment in 2018, the projected employment in 2028, how much it's going to change, how many openings there are, the wages, blah, 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 blah. So we can see all this fun stuff. Great, so now we've got our BLS data. Now let's check out our O Net data. So our O Net data can be found from this link. So I hyperlinked it here. And basically here's a database of all the components of each occupation. So I think for this, we used activities, really because I think you can think of an occupation as being able to be decomposed into the activities. So this is something that gets a lot of attention as people talk about automation, because of course occupations as a whole don't get automated, but tasks and activities get automated. So, so it's useful sometimes to think about occupations as just a set of activities that are done. So, so we have work activities. So you could download this as an Excel file or as a text file. Usually text files are easier to read into Python because they're so lightweight. Excel is a very highly functional program, so there's a lot of like bulkiness to the file. But text files are really small, really clean. So we can copy and paste. We could do copy link address, same way we did before, and we can get the URL here. So there we go. That's the URL. We are going to read this in. So we read a CSV. So CSV is comma separated values. Every text file uses a kind of CSV format, but the separator is not a comma, it's a tab. So which is why we need to separate it as \T for tab. So we can read that in, and that might take a few seconds. By the way, here's a fun little trick. If you want to see how long something's taking, you can do % sign time at the top of your cell, and then run it, and it times how long the computation takes for the cell. Anyway, so 4.5 seconds. Okay. So so now we get the header, so we can see kind of what the data looks like. So we get the element. So there's a set of elements here. There's getting information. That's an activity. There's monitoring processes, materials. There's identifying objects. That's an activity as well. So there's a bunch of people who work for O Net who identify what are the activities involved in jobs. There's really, you know, a team of people which do this. I think probably a lot of organizational psychologists. So there's the scale ID, which says whether it's this value refers to the importance or the level. So for every job, you have, so this job is, I mean, we'll see what this job is. We can kind of look it up. It doesn't say the occupation name, but 11-1001, this is chief executives. Chief executives, have, for getting information, that's got a value of 5, but the importance is 4.7. So there's an importance and a value for every job. This is based on a survey. So this is the sample size in that survey. Not very big, but hey, what can you do? Okay, so that's what the activity data looks like. Now the O Net code is actually not exactly the same as the SOC code because it's got 2 extra digits. So there's about 800 occupations in the BLS data, but like 1,100 occupations in O Net. So we basically want to get rid of what's after the period. So here it's a string, we're splitting it by the period, and we're just including what's in the beginning. So the first element. So then we get a column called SOC code. Okay, so a little bit of string cleaning. We're gonna have to do that basically every time we read in new data. It comes with some messiness, you gotta clean. Fine, then, so we have this data frame called activities, and we wanna merge in some information from the Bureau of Labor Statistics. So BLS has data on the SOC code, the occupation name, which is useful, we'd like to see more of that, their current employment and their wage. So that's kind of the information we want. It's a pretty simple command. It's just .merge. So we do activities .merge, and we're merging in this BLS. Here is how we're selecting the columns for BLS. So if you want this data frame with only a few columns, here, let's see what that looks like. This is just a limited version of that data frame. So we're going to merge on the SOC code. That's the identifier that's common between these two. It's an inner merge, which means we're not including things that are not in both data frames. Okay, so now we can look at activities because we overwrote that data frame with now the version of it that has this other information merged into it. And now we see the occupation name, we see the employment, and we see the wage, which is great. We've got a lot of information now. All the information we'll need. Okay, oh, we had a question. What's the standard error telling us? So the standard error is our uncertainty about the estimate. So for all of you who have taken stats, standard deviation is the variance of a variable, is a measure of variance of the variable. Standard error is the measure of variance of a parameter. So a mean gets a standard error, and this data value is a mean. So every mean has some uncertainty to it. So that's how we'd interpret the standard error. So even though we get a value of 5.35, we really know that with 95% confidence that it's between 4.89 and 5.81. Yeah, so if we did a different type of merge, let's say we did a left merge or an outer merge, let's see what that looks like. So now we could look at activities, and it looks mostly the same, but there might be some occupations that were in the O Net data that's not in the BLS data. So then we can select, if we want to select data, we do .lock. So .lock is a way to select data based on some characteristics. So we can say wage is null. So we can see what's null here. And we can see that this occupation, this 13-1021, was not in the BLS data. So we don't have any information about it. Yeah. So, you know, these just all end up as nulls. Or actually, maybe they don't, but if we do that are null here, these are all the things that were not merged in. So there are a few occupations that we just don't have data on, and we're just going to ignore them in this case. Okay, so let's stick to an inner merge for now. And now we see that none of them are null.
Yanis was asking, and you mentioned this a little earlier, can you repeat what the inner merge is?
Oh, yeah, sure. So basically, the inner merge only keeps identifiers. In this case, the identifier is the SOC code that is in both the activities data frame and the BLS data frame. If we do a left merge, the left data frame is the activities data frame. It keeps the things that are in activities but not in BLS. If we do a right merge, it keeps the things that are in BLS but not activities. If we do an outer merge, it keeps everything. So Mariam will know all about this because she teaches SQL. Very common thing to do in SQL. Okay, so we're going to do all this merge. And now after we've done an inner merge, then nothing is null when we when we select the employment in 2018, which is great. That's kind of what we want. So now we can see what this data frame looks like. And here is actually, this is a little bit fancy, a little bit overkill. But basically, what I think we want to do, I think we'd like to get a data frame which has just the mean value of the level of each activity by each occupation. So that's really what we want. Now, some occupations are repeated twice. So just because there are more O Net occupations, excuse me, than BLS occupations, we kind of need to take the weighted average. So it probably would have been fine if we just took the average, but just to be really precise, I thought it would be cool to take the weighted average. So basically, to take the weighted average, we need to, basically the formula for the weighted average is the sum product of the weighting variable and the value divided by the sum of the weighting value. So we actually created this this employment. So we're weighting by employment. So we want to give high weight to the occupations with a lot of people and low weight to the ones with very few people. So we created just the product of those two things, employment times the data value. And then we are filtering to just the level, and we are grouping this by occupation and by this element name. So the element name is the activity. So we're grouping by occupation and activity. And what we're grouping, we're summing up the employment, which is the weighting variable, and the value times the weighting variable. And then to get the value, we actually divide by this product over the weighting, over the sum of the weighting variable. So it's a little bit involved. If you followed this, then great. Yeah.
We've got a request for a repeat for a bis.
Okay.
But
Great.
slowly, yes.
Okay. So basically, what we're trying to do is this group by. So here, let me show you what this would be in a very simple format. So we want to take activities which have been filtered, right? So this is just the data frame where we only get the levels. We don't care about the importance. Then we'd like to group this. So we want to group by occupation. Here, if we want to group by multiple things, we put it in brackets. We want to group by occupation and this thing called the element name. We can just copy that and put it there. So that's what we're grouping by. And what we want to group is the value. So we can group by this thing, data value. And we want the mean. So this is what we get. We get accountants and auditors get analyzing data and information. They get a score of 5.2. Assisting and caring for others, 2.4. Don't tell your accounting and auditor friends. So that's really what we're trying to end up with. But it's not exactly right, because within accountants and auditors, you might have accountants and auditors tax, accountants and auditors management. So you might have two sub-occupations. So you don't actually want the mean of the data value, you want the weighted mean. So just the formula to get the weighted mean is to take the product of some weighting variable. In this case, let's do employment, because that's a reasonable way to weight bigger occupations more than smaller occupations. And the value that we actually care about. So we really only care about the value, but in order to take the weighted average, we take the sum product. So this is the product, and we sum it up. So in the group by, instead of doing mean, we're going to do sum. And we're going to sum this product variable and the weighting variable. And then after we've grouped it, we're going to have this data frame, which we're going to call activities occupation level. And then we're going to create a new value called a new variable called value, which is going to be this sum product, which we just created, over the sum of the weighting variable. And that value is going to be very close to what we had before with the weight. So let's actually see what it does. Here, let's run this, and let's see activities occupation level. And we see that it's basically the same. There might be some cases where it's like a tiny bit off. But if you do want to just use this instead, that's perfectly fine. I just, you know, got a little carried away. Okay, so we can see this this data frame here, and it's a tiny bit more precise. Okay, once we have that, we have this occupation level data, and what we really want to create is a table where we have occupations as the index, where every occupation is a row, and every element is a column. So that way we can treat every occupation as its own entity and treat each element as a variable. So we can see how each occupation scores. So what we're going to do is we're going to make a pivot table. So pivot table takes the index, which is the rows. We're going to say the index equals the occ. The columns equals the element name. And the values equals the value. And we're going to create something like this. So this is what it's going to look like. It's the occupations on the left, the values on the right. And if we scroll all the way down, we can see this is 752. We have 752 occupations and 41 columns, where each column is an activity. So we see, so every occupation has a, in machine learning parlance, it's every row is called a vector. So every occupation has a vector representation. And that vector representation really summarizes the activities that it's doing. So imagine that you have a data frame with only 2 columns, and each column is a set of numbers. You can imagine a scatter plot that has 2 of those things, right? Everyone's seen scatter plots, right? So that scatter plot is in 2-dimensional space. If you have a 3rd column, you can sort of think of that as every dot belonging in 3-dimensional space. If you have 4, you can think of every dot belonging in 4-dimensional space. So now, if you like thinking in this way, you can think that we are defining every occupation as something that exists in a 41-dimensional space, where every dimension is an activity. So the useful way of thinking about every occupation as some dot in high dimensional space is that we can compute distances between these dots. And that turns out to be really useful. And we get to see similarities between these occupations as distances. So here's what we had. We created this this activities data frame, this rep activities. Let's see if this ran. And we can see what that looks like. Yeah, so basically what we showed before. Okay. So if we want to visualize this high dimensional space in low dimensional space, we use this package we installed called tsne. So again, tsne stands for T-distributed stochastic neighbor embedding. It was actually invented by the same guy who invented deep learning, Jeff Hinton. And basically what it does, it tries to find very close points in this high dimensional space, and it creates 2 dimensions that that try to maintain the character of those high dimensions. So what we can do, we can transform this activity, this rep activities. So this is the format of the data that it needs to be in order to feed it into tsne. And then we're going to turn it into a data frame where we've got columns, and yeah, that's it. And we're going to call it tsne 2D for 2 dimensions. We can time it. It's going to take a few seconds. And let's look at this. tsne 2D. Okay, here's what it looks like. It's got this occupation and this column 0, this column 1. Now,
I have a quick question.
Yeah, sure.
Sorry for interrupting. I'm just wondering, for all those functions, can we find them somewhere online, or do we have to know them by heart?
Yes, you can absolutely find them online. Yeah, it's really hard to know by heart. I don't know them by heart. I don't think many people do. Basically, if you wanted data on tsne, so I posted a hyperlink here, and you can see this goes to the scikit-learn page. And here's the documentation for how it works. if any of you are unfamiliar with scikit-learn and machine learning in Python, it's like got a super friendly documentation. Here, if you go to the homepage, it shows classification, regression, clustering, all this stuff. Dimensionality reduction is what we're doing now. We're reducing high dimension to low dimension. Yeah, they have just tons of resources and explainers. It's really great. Also, by the way, the person who invented scikit-learn also has a great set of lectures online. He used to teach at Columbia. He just left. I'll share his, whatever. I'll share it later. But yeah, so that is, yeah, basically anytime you want to look into these functions, I mean, you basically just Google it, and the resources are usually very good.
So Ben, there are a couple of questions.
Oh, sure.
Like what
Thank you.
inspired you? Yeah, go on.
Sorry?
What inspired you to actually use TISNET? And then why did you choose to go with 2 dimensions instead of 3 or 4?
Yeah, so basically, so the first one is, I'll answer the second one first. So basically, I just wanted to do 2 dimensions so that we can visualize it, because, you know, it's really hard to make 3-dimensional plots, although some people do it. But 2 dimensions is just how we're used to visualizing things, and 4 dimensions, that's not possible to visualize, at least not for humans. So it's got to be 2 dimensions. There are different ways to reduce the dimensionality. So basically, one very common method is called PCA, Principal Components Analysis, and that's really for maintaining information. It's not really designed for visualization. So TSNE is designed for visualization because then you can hover over things and see what's close together. So it's really useful if you want to see what's close. And that's kind of what's coming. TSNE is the standard way of doing this. There's one new one called UMAP that just got introduced. It's actually really cool, but I don't know, TSNE is more standard. So just went with that. Yeah, any other questions?
Nope.
Okay, so we've done all this work, and we need a payoff now. So we've got this 2-dimensional thing. We can also merge in the BLS data grouped by occupation, where we've got the employment and the wage, and we're going to merge on occupation, another inner merge, and we're also going to create a variable called the square root of employment. I'll tell you why we do that in a sec. So now let's look at the TSNE 2 dimensions. So we've got these dimensions. Now we've got some variables. Now it's a whole data frame that we have. And we've got the square root of employment. That's really just because when you visualize, we want employment to be the size of the bubble. And for whatever reason, visualization packages, when you put in a size, it uses it as the diameter. And I think that's a really weird, silly choice. So if we want it to be proportional to the radius, we need to take the square root, because the radius is, you know, pi r squared. So we just take the square root and we raise this. So unlike Excel, if you want to raise to an exponent, it's multiply, multiply, rather than the little, I don't know, it's not this signal, this little widget. So we raise it to the 0.5 and we get a square root. Okay, so now we've got square root of employment. Okay, so now we can run this scatter plot. And there we go. So now we have dropped nulls, and we have plotted the x is this 0th dimension, dimension 0, y is dimension 1, and we want to hover over occupation. So now we can see purchasing managers are close to personal and financial advisor, labor relations specialist, whatever. So all this stuff, so we can see what's close. Here we have secretaries, blah, blah, blah. So the size of the bubble is now proportional to the size of the occupation. So we can see these 2 things. This is judges, and here are lawyers. Kind of makes sense that they're close, but there are a lot of lawyers and not so many judges, which makes sense, which is why we want lawyers to be big, judges to be small. By the way, if you have run this yourself, you might see this a little bit differently. So you might see judges and lawyers all the way on the bottom left. It's kind of random. There's a little bit of randomness to it. So every time you run this, you might get a different shape, but it'll mostly work the same way. And we see high wages are in yellow and low wages are dark. So over here, we see a dark cluster, childcare workers, that's unfortunate, food servers, bakers, lifeguards. These are low wage jobs. Over here, we see some high wage jobs, nurse, anesthesiologists, nursing, physicians and surgeons, kind of makes sense, they're high wage. Psychiatrists, those are high wage. Computers and information. So as it gets, you can sort of see the wage spectrum. And this is kind of cool. I mean, we get to visualize, you know, the occupational landscape. So just, and remember these things, what dictates whether something is close together is whether they are close in terms of their activities, right? So we have this high dimensional space, which is activities, and we reduce that. But really, I mean, the distance is the distance of how similar or dissimilar they are in terms of the activities that they're engaged in. Does that make sense?
Yep. And then there's another question. How would you have differentiated between public sector lawyer and private practice one?
I don't know. I mean, whatever O Net does, you know. So I think really O Net has their own occupational classification, and I think what you're really getting at, to be honest, is really about the industry. So the same occupation might be paid very differently in industry A versus industry B. So in Bureau of Labor Statistics data, you actually can see the differences in average wages, not just by occupation, but also by occupation in an industry. And also, I think by MSA, which is Metropolitan Statistical Area, by city. So you can see maybe, you know, lawyers in the private sector in New York get paid a lot, but in the public sector in Georgia, maybe not so much, who knows? So you actually can see this if you want to get deeper and deeper. But for now, we're just taking national averages. Okay, so now that we have all these distances, it would kind of be cool to see what's close to what. So we can actually compute the distances using this dist function that we imported here. I'll show you, share a link. And as this is opening, Giannis, that's another question. What data set would you recommend to try this exercise as homework? The BLS data and O Net data. I think, yeah, I'll give all of you some homework for next week's session. But yeah, I mean, if you go to these links that are included in the notebook, they link to some more data sets that you can just mess around with. So here with distance, there's something called cdist, which computes the distance between a pair of two collections of inputs. Basically, what that means is this representation of activities. We do that twice, and then we get this distance of activities, and we see an occupation by occupation distance. So here we see accountants and auditors to itself has a distance of 0. Of course, so it's 0 all across the diagonal. And so if we want to pick an occupation and see what's similar to that occupation, we need to first find the name. So we can actually search by the substring. So let's say we want to look at HR occupations. We can search, and we see here are the occupations that are relevant to, that have human resources somewhere in the title. So let's say a lot of you are human resource managers. Let's say we want to take human resource managers, and we want to select this, right? So let's say we take dis activities, and we just select human resource managers. We get the distance to every occupation in alphabetical order. That's not so important. We don't care about the distance between HR managers and zoologists. So we want to sort this by what's close. So we do sort values, and here we get the most close occupations and the most dissimilar ones. We can look at just the header of these. We can look at the top 10. And we see it's pretty close to education administrators, training and development. That kind of makes sense. Medical and health service, labor relations specialists, that one makes sense. Chief executives, that's pretty cool. So we see that HR managers are close to chief executives. Here, I actually went a little bit of a step further and merged in some wage data. So, so let's say HR managers on average make $116,000 a year. Not bad. Is there anything in this list that's higher? So we can go through and we see, oh, chief executives make more money. Maybe that's a good career step. So we can see we can actually see the distances. So not just the distance, but we can see where the gaps are that we want to build. So for all of you who are into training, we're running a little short on time, so I won't go through this code in so much detail. But basically, we just looked at the gap. So it's the target minus the source, and we sort from high to low. So where the gaps are, and we could do target minus source, and we sort low to high, so we can see where the gluts are, where the excesses are. And we just look at the top 6. So here's what we find. If you're an HR manager and you want to be a chief executive, drafting, laying out, and specifying technical devices, parts, and equipment, something to learn. Communicating with persons outside of the organization, that's something you got to learn. That one rings a little more true than the first one, I think, to me. Inspecting equipment, I don't know anything about that, but interacting with computers, monitoring processes, material surroundings. Okay, great, all stuff to learn. Here's stuff that you will probably do less of. Assisting and caring for others. You could say goodbye to that if you're changing careers. Staffing organizational units, resolving conflicts. So you can kind of analyze the differences between occupations in terms of activities. So that's kind of cool. That's another benefit of using this data, because it does give you all this detail. Okay.
So Ben, I know we are running a little close to the end. Is it possible to just give some homework? Because I think a lot of the things is really spending quality time with this workbook and digging in through the links and poking around. What should the students do for next week? Yeah.
So it's actually a perfect time when we got to the end of everything we want to do, and then we're just going to polish it up and make it super nice and tidy. And yeah, so if you really want to go deep into this, I'd say just read in the data. Make sure you can read in the files and see the objects, see the data frame, and try poking around, try filtering. There's a lot of things in this notebook that you can explore in very, very much detail. Filtering data is a whole thing. Grouping, group bys, merges, cleaning, sorting. All this stuff is something that you can really spend, however much time as you want, just kind of fiddling around with. So I'd say read in the data, fiddle around, make sure that every line here kind of starts to make sense to you. I think if you get to a point where you can read through this notebook and it all makes sense, you're in great shape. And refer to the NYU Data Bootcamp sources if you want. There's, of course, lots of sources online. That's just one of them. And you can, of course, email me and write to me on the Slack channel if you have any questions. And yeah, we'll pick up next week. And
can you give us a preview of what next week will look like?
Yeah, so next week, we'll make this more polished. We'll add titles. We'll change the font. We'll make this a little nicer, and we'll make functions. So we'll make functions so that we can do everything we just did with like one line of code. We can do this representation that does all this code in one line. We could do it for knowledge, for skills, and we could do this excesses thing also in one line. So we're just going to make some functions. We're going to define this hover plot so that we can do the hover plot in one line. And yeah, we're going to search. We're going to find similar things. It's really just more of the same, just making it like accessible in like 3 or 4 lines so that it's like productized.